Uh, uh, Good morning. Hi, hello. Morning. Thank you. Morning. Uh, sorry, I'm taking a look at yesterday's tree thing. I was like looking at other people's solutions, and I'm happy because I know how to do it programmatically. But here's one solution I found. It branches out, and it looks really similar. Wait, I'll pull it up. Yeah. Yeah. This one. I mean, mine is a lot less clean. My version is a lot less clean. But I feel happy that if we just take a look at the top, um, 11.5, 11.4, 39.5, and it stops. And then importantly, how they highlighted the places where there's a 1, because that's where you're gonna do the addition. And then in mine, I got the same thing where, yeah, 1. It just looks really, it looks much better in this code version. Um, I just don't know how to do it, and meow. I am not really looking at the rest because I don't understand it. Mounting, mounting. Solo. Meow, 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 meow. Meow. Hello, hello, hello. Yesterday I was trying to see if I could do a tree with types, but there are a couple of packages for that, but I don't know how to do it. So, anyway, try not to get stuck here, but it looks like I only answered the first half of the problem, so I don't think I can move on yet, unfortunately. Still nice to just me. 11. See. Um, meow, 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 meow. I'm muted. Yeah. Ah, 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 ah. I don't remember the lyrics to that song. Meow, 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 meow. Meow, meow. Wait, I can't think. Let's think. Meow, meow, meow. Meow, meow, meow. How does the song go again? Mm, I can't think of the beginning. I can only think of the chorus. Yeah, I like that song. Man named Mexico. Wow, 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 wow. Okay, enough of this. Move back. This. Draw the tree illustrating the process generated in making change for 11 cents. But I didn't answer these questions. What are the orders of growth of space? The number of steps used. Mm, the number of steps used by the process as the amount to be changed increased. So meow meow. Hmm. To be honest, I read this section on orders of growth, but I did gloss over it. Hmm. Let n be a parameter that measures the size of the problem. Let R of n be the amount of resource. In our previous examples, we took n to be the number for which a given function is to be computed. But there are other possibilities. If our goal is to compute an approximation to the square root of a number, we might take n to be the number of digits accuracy required. For matrix multiplication, we might take n to be the number of rows in the matrix. We say that the amount R of n has an order of growth theta f of n, theta of f. If there are positive, yeah, and I positive constants k1 and k2 independent of n, such that k1 times f of n is less than r of n is less than or equal to, less than or equal to k2 times f of n. For any sufficiently large value of n, for large n, the value of r of n is sandwiched between these two. Growth. If there are positive constants independent of n, that allows r of n to be any nadir. With the linear recursive process for computing factorial, the number of steps grows proportionally to input n. Let's take a look at that. 1.2.1. That's a while ago. Here. Here. Yeah. So, yeah. Because, yeah, if this was like some bigger number, this would be way, way, way bigger. Okay. That works out. No, I'm not amazing, but thank you for stopping by. In fact, the coolest part of learning programming specifically, actually just anything, learning anything, is seeing how much I have ahead, honestly. I hope I can live 10 more years so I can spend the next 10 years learning more. Hope I don't die yet. Mm. The steps required for this process grows as theta of n. We saw that the space requires grows theta of n. For the iterative factorial, the number of steps is still theta of n, but the space is theta of 1 that is constant. Okay. The tree recursive Fibonacci computation requires theta phi to the n steps, but space of theta n. Ah, okay. So like steps in space. How do we so I feel like yeah, steps seem to be like how how long, and space is how deep. If I'm understanding it correctly. Because it did say that so for Fibonacci we have two examples of the trees. We have or not just the trees. We have two examples of how to solve the problem, right? You could solve it with the recursive process or an iterative process. With the iterative process, there for factorial 6, there's 1, 2, 3, 4, 5, 6, 7 steps. Maybe that's not the way to count it, but I think yeah, these are the number of steps. But the space, it only goes out like this far. It doesn't get, it's not like the recursive process where um within each step there's like a space of depth, right? Like you only in the iterative option you only need 3 things for each step. You need 3 numbers. But yeah, for factorial, it really not they're both factorial. Within the recursive process it grows. I don't know how to do the math for that though. Maybe there is a way. Wait, let's look at that again. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Actually, I don't know what counts. I don't know what counts as a step. So maybe 12, maybe 11. 1, 2, 3, 4, 5, 6. Let's take a look at that one more time. What it's the thing that's throwing me off is I don't understand what the theta mean, but it's okay. Okay. Um. mm, um. The linear recursive process for computing factorial, the number of steps grows proportionally to input n, so the steps required grows as theta of n. Okay. The space also grows as theta of n. For the iterative factorial, the steps is still theta of n, but the space is theta of 1. So it's constant. It doesn't grow like linearly as theta gets bigger. The tree recursive Fibonacci computation requires theta phi to the n steps a space. I want to think about that. Phi to the n steps theta of n for the space, and then phi is the golden ratio. So that is like right. So we have steps and then we have space. They said the steps have phi to the n. But the space is n. That how you calculate? Ah! Sorry, I'm trying to remember what phi was. Divided by 2. I'm pretty sure that's phi. Phi to the 11. I don't understand this, but whatever. I don't think so, Fissy. It doesn't seem like that kind of book. Now, that said, though, one of the things I'm doing kind of wrong is that this book is written for a course and there are lectures. I should be watching the lectures in tangent, but I haven't been doing that. Anyway, let's see. Let's see about I want to make kind of. I don't know how though. I don't know how to make it. Let's see. I'm looking for it. Why is DuckDuckGo so badly? Hello? Meow, 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 meow. Document. Um, I don't know where they have packages again. I forget. Plugin. Over here. Not what I'm looking for, though. Community. Um, um, ah. Gonna cry. I'm actually gonna cry. Oh, cute. Oh, cute. Oh, cute. Like kitty. Mm, tree. Not tree. Oh. Um, 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 mighty. Um, not tic Um, meow, 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 meow. Okay, this is what I need. I think this one looks simple. Oh yeah, let's get this one. This one. Copy this into your project and use the import verbally. Um, import emoji face. Now, put up types multiple files called module. Yeah, good. Anyway, package import whatever. Try it. Let's just try it. Get in there. I mean, local package. Never mind. My thingy. I didn't get good sleep last night. Really tired. Really tired. Super duper tired. Did I mention I was tired? Also, I'm sleepy, by the way. Tired. And then this here. Oh yeah, I was tired and then I'm tired again. I'm retired. Ha ha ha. Ha ha ha. Ha ha. Silly girl. Memes. Meow, meow. I woke up today and the first thing on my mind was like, there's literally gonna be super intelligence that can do everything I ever wanted to do. And I think for a moment, like, what is the point of anything? But I don't think that's a useful way to think. So I tried to like only think like that for a couple of minutes, and then I was like, okay, time to get up now and do things. Enough wallowing in pity and self pity. Meow 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 meow. Um, um, one here for um. Okay, here's what I want to figure out how to do. I want to figure out how to rename a file that I'm currently working on while in Vim. I want to see if that's possible. Maybe it's not possible because I'm in it. Let's see. Oh, in the current working file in. My hair is falling out, guys. My hair is falling out in clumps. Save as new file. Writes the current buffer to new name, keeps editing the file, old file still. If you want to remove the old file after execute shell command, one liner save, which saves a new name, deletes it using Vim scripts. What's the point of anything? Well, I can understand the point of cuddling a cat. Because cats are so good. They're so good and cute. I can understand the point of games too, for the same kind of reason. Like, games can make people happy. Anyway, I think that I'm just sad, so that's why I'm thinking this way. No, it's probably not something useful for me. Work up. Should I just shave my hair, my whole head off? And then I can post on the bald subreddit. I love how that one's always trending and popular. There must be a lot of either a lot of bald people or like it just gets a lot of engagement. There's a lot of people worried about becoming bald. Yeah. No, I haven't seen that porn music video. What's PMV? That's the only PMV I know. Is that what you mean, by the way? I don't like anything. Okay, let's try this. I like Vim. Let's do Vim. Save. Five. Wait, 1 4. Mm. Parody music video. Oh, you're not. I'm just a gooner. Anyway, that's embarrassing. I should not speak anymore. I really, ah, I should never talk again. Ah, I'm trying to quit. I'm trying to quit. Um, did you find a candidate for your Discord kitten? I know I'm looking. I told you where to find them. I don't know how much what else I could tell you. I practically gave you, I led the horses to water. Told you where to find them. That girl has no filter. Ah, ah. Anyway. Oh, meow. Tip, 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 tip. Okay, let's go in that one. Meow, 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 meow. Okay, and then in here, actually, I don't know how to do this. Oops, I didn't mean to do that. Let's see. 14J, XX 3J. Meow, 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 meow. And then, what else did I want to do? I don't know. Oh yeah, let's go to the top. That's not the top. I always forget. What is G? I feel my hair falling out. The uncomfortable. Like I could feel it tugging. Anyway, let's see. This B stand for no. E and GG. What does that mean? Oh, reporting results. Yeah. Go to line. Oh, wow. La. G means go. GG means first. G means fine. Okay, fine. Okay, fine. Whatever you say. Let me put this in here. Uh-oh. We're gonna import this thing. And then we're gonna... Oh, how did we do that last time again? It was in here. We went... I forgot already. I should write things down. I should write things down. What the heck is it? Was it just S? Was it S? What was that do? L? Oops. That's not what I meant to do. Well. Uh, uh, um, uh. That's not it. Meow, meow, meow. Oh wait, it's saved. Look at this. It's saved. Wait. All my thingies are in here. Okay, this is so good. It's types compile. Okay, you just put a, what do you call it? You put a exclamation mark and then you do the command. That's what it is. That's what it is. Anyway. Oh, okay, fine. Fine. Download if you want. Jeez. Okay. Pop-up is so like, what do you call it? Controversial, risky. Popping up on my screen like, boo, hello, boo, hello, boo, 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 boo. Okay, let's do this. Oh, that's really awkward. How do I do code blocks again? Is it just whatever? We'll figure it out. We make it up and figure it out. Make it up and figure it out. So this problem said draw the tree illustrating the process generated by the count change procedure, which is this thing here. So the blue screen is just a really, really tiny screen mirroring of my tablet where I drew the tree from scratch on Procreate. But I'm gonna redo this in code or using using our using types is the goal. Yeah, that's what we're gonna do. Anyway, I wanna first wait. How do I insert on multiple lines? How to insert on multiple lines using Vim. I know it's a visual something. Okay, V some control control V and move up and down and then capital I. Okay, let's try it. Control V. Let me go here. Oops. And then Shift I. That didn't do anything. I think I'm doing it wrong. Control V. Oh god, I'm in trouble. Oh, it didn't work. Wait, I thought it didn't work. Control V. 12J. Capital I. Then I think that's it. I don't know how to do this. Wait, I don't think that's what I want. Wait, escape. Oh, I don't think that's what I wanted though. I don't think I'm doing this right. Wait, let me go back. Let me go back to the docs. Wait. Oops. Docs. Meow. Have you played the Vim tutorial? Nope. Nope. I heard that there's a mini game though, but I haven't played it. Hi, Kitty Pillar. Let's see. Control V Shift I. Thank you, Hackleforth. I didn't read it fast enough. Now I want to know. Code block. How do I do that? Meow. Writing and formatting. I don't know. Let's see. Text. Is there something else? I'm upset. Can you just show me? Can you just tell me what I'm looking for? Man. Code block. Scripting chapter maybe? This is not what I want exactly. Not what I want exactly. Maybe it's just backticks, maybe. I don't know. Let's go back and Control V, 12J, and we're just gonna get rid of that. And then I feel like crying. Okay. Maybe it's like oh, I think that's it, boys. Maybe? Maybe? That's it? Yay, we made a code. We made the code. We made it like code. But I wish I could make it look prettier, but that's okay. Draw the tree. Oops. Back 3 words. That's not. Nope. I did that wrong. Wait, nope. Did that wrong. That's good. Let's try that again. Go up 16. I want to go to. How do I do the next? Is it E? What's it? Is it F? You know how you could. Oh, forward T? How do I do next one? Forward F? Never mind. Anyway, let's see. Draw the tree, illustrating the process of count change. Oh. Meow, 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 meow. So let's do the tree. Now we have this guy. Where's this guy? Arborly by what's his name? His name is Max. Oh my god, guys, it's Max, my teddy bear. My teddy bear made this. Thank you, Teddy. Thank you, Max, for making this package for me. I'm not gonna lie, I want to click this button. I'm not gonna click it. I want to click it though. It has the same name as my teddy bear. Mm, meow meow. Okay, so to use it, hashtag tree with brackets, and then tree goes here. But let's see. So click the button. Click the button. Click, 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 click the button. Click button. Click, click the button. Okay, so then let's see. So if we have TP, NP, and this is one branch. I'm trying to understand the freaking syntax. Where does VP come? Okay, so TP, NP, and VP are kind of like in the same indentation. And then yeah, and then VP has V and NP, and V only has one thingy. So if you only have one thingy, it just goes like next to it. But if you have more thingies, they branch underneath. Let's just try it. Let's try it. Okay, I think I understand the syntax now. I probably don't. It's fine. It's fine. How bad could it be? Okay, let's give it a try. We're gonna convert this behemoth into a tipstree. Let's start at the top of the tree, all the way up here. It's like logic puzzles on coke. Three. Then we need brackets. Okay, let's see. Three. Man, man, man. Oh man, how do I do this again? Let me think about this. I'm nervous. I'm nervous. 11-5. I'm not confident. I have no confidence. TP. And then I have to open a new bracket when I want to branch out, right? New bracket to branch out. we brought you a tungsten cube 1 by 1 meter, would you be happier? Yes, I would be much happier. Yes. Yes, I would be. Are you gonna buy me a tungsten cube that big? I don't know if I could carry it. That sounds really big, but it would make me happy. Oh, I got excited all by myself. Stop playing with my emotions. This is like the time that my dad promised that um, you know? Let's see. So we have 11 4. That's one branch. But then we also have -39 5. That's another branch. And then that one goes straight to 0. It goes like this. Okay, and then I want to see what this looks like. Let's compile it. Oops, I did something wrong already. 3. I need a space. I need a space. 7. Nope, it still doesn't work. Okay. What am I doing wrong? I thought I imported it. 3. Import tree. Oh, I forgot the tree part. Okay. We go to the GG for the top, and then we go to N, and then we A, then we want tree. Let's try this. Oh, I think it worked. I think it worked. Which one likes tungsten cubes, evil or neuro? I don't know. I don't watch them, but I like them too. Yeah. Would that be it? That would be enough tungsten to pay for college education? I want it, I want it, I want it. Wait. I want it, I want it, I want it. Oh, wait, why isn't it working? Man, what am I doing wrong? Wait, do I have to do it? No, that's not what I wanted to do. I wanted to go down by 19. And then I wanna this. Go down 4. And I wanna steal it. I steal it. I go back up. And then I go down 1. I print it here. I wanna thing over there. And then I wanna go down. What the heck am I doing wrong? Hey Gunnar, you've been working hard. Doesn't matter if you can't figure out immediately. Oh wait, I thought I thought you meant like the opposite of what you're saying. Keep it up. Are you telling me to keep up my I don't have a boner. I don't have a penis. Sorry to disappoint. Not a femboy. Oh, let's see. What the heck am I doing wrong? Is it my indentation? What am I doing wrong? 3. Okay, wait. You know now. Wait, now it doesn't need a base. That's what it is. Yeah, there we go. Look at that. We're debugging. This is called debugging. Boys, look at it, look at it, look at it. We have a tree. Wait, are you looking? Did you look? Did you look? Did you look? It's ugly, but it's a tree. We're making a tree. I'm so excited. Okay. Um, fuck. Oh, let's. I kind of wanted to have the thing though. I kind of wanted to have CC because it makes more sense. But yeah, like this. Okay. Um. Wait a minute. Why didn't it work? Why didn't it work? Oh, because I didn't save it. always gotta write. Yeah, yeah, this is what I'm talking about. This is what I'm talking about. I think it looks better without the letters, so we take out the letters. Okay, maybe I put a comma. Maybe I put a comma. Oops, oops, oops. Maybe I put a comma. For human readability, there are no commas. Okay, yeah, the comma looks a little bit. No comma or comma? I think a comma is more readable, but technically speaking, in the code there wouldn't be a comma there. I'm co-working, auditing forms. Why is programming so interesting at this moment? I don't think you can call this programming. You call this a cat girl doing silly things. Doing silly things. Okay, let's do this is like the meme. You make the beginning of the tree and now we gotta make the rest of the tree. Shit. Shit, we gotta make the rest of the tree. This is God. Oh God. I don't even know how to read my own handwriting. This is gonna be terrible. Let's see. Okay. We got this. We'll take it slow. No, ignore the squiggles. Mm, oh, man. Okay. I'm not gonna look at it for a while. Let's just focus on doing the process. That made sense. I'm looking. Play some piano music. Meow, meow, meow. Okay. So 11:4. Branches out twice. Oh, oops. This 11:3. 14:4. YouTube good. Okay, let's think. Let's think. Use brain. Use the brain. Okay, so we did 11:4. Now we gotta move over to 11:3. I keep wanting to use my mouse, but I don't have it like I'm not using like sidecar. Can't use my mouse for this. Okay. 11:3 then branches out to 11:2 and 1:3. 1:3 also branches out. Oh, okay, we'll go with 1:3 first. So we're gonna resolve. Just trust me. I don't know how to explain what we're doing, but just try to trust me. We go to 1:2 and -9:3. And that goes to 0. Okay. Now that we've solved this part, we need to do the 1:2, which branches out like this. We go back in here, 1:2, and this goes to 1, 1, and -4, 2, which ends at 0. And then this 1, 1 branches out at 1, 0, and 0, 1, which gives 1 and 0. I'm already lost. Oh man, I need to be able to keep track of bracket. Wait. I think that's it. Placement of data in tree as a binary index. Those are some words. I don't know what those words mean though. I should have done was encode the placement of data in a tree as a binary index. I don't know what that means. Oh, meow, meow. 0 left, 1 right. Yeah. Meow, 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 meow. I feel like I'm gonna be missing front end brackets. My brain hurts. Okay, let's go back up a little bit. Um, this. Yeah, I definitely did something kind of wrong. This should be the end of 11.5. And then 11.4. Wait. Should include. My brain hurts already. Put it. Gonna be at the end. I'm afraid to go any further. Give me a second. Let me look at the docs one more time. Okay, because it ends like this. This is the beginning of the tree. This is TP, this is NP, this is VP. Meow 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 So it seems like the only places where you're gonna have 2 brackets right on the end is when the actual node closes. Okay, so with that knowledge, doesn't go there. Oops. I'm in so much trouble. Meow, 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 meow. I also forgot. Okay, I definitely broke the tree. Okay. I think I just gotta finish the whole thing. I think I just gotta finish the whole tree. Meow, hi. What's your code? Goes beyond 5 indents. You might as well give up. You're gonna lock me out. You want me to go to jail? You want me to go to jail? Meow, 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 meow. Okay, let's start again at the top. This is 11.5 splits into 3.9 and 11.4. 11.4 splits into 11.3 and negative 14.4. 11.2. Wait, let me think about this. 11.4, 11.3, and 14. And then it stops at 14. 11.3 further splits into 11.2 and 1.3. And 1.3 further splits into 1.2 and 9.3. 1.3, 9.3. 1.3, 1.2, 9.3. And then the 1.2 further splits into 1.1 and negative 4.2. And then the 1.1 further splits into 1.0.0.1. Okay, we're good. We're good. We're good. I think we're good. Okay, so that closes off the 11.3. Is there a way I can highlight? That's what I should do. Give me a second, boys. I gotta close this for a second. I forgot to. Oops. Every time you use the Apple, you turn on your iPad again and you want to use the Apple Pencil, you gotta plug it in the bottom. And then I gotta replug it. Meow, meow, meow. Okay, so now it should work. Yeah, it works. And I plug this back in. Meow. Meow, 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 meow. I'm really hungry. Okay. So first I think what I want to do is I kind of want to get rid of this whole red outline that I did because it just looks more confusing. And actually I want to get rid of these two. I should have done this on different layers. Okay, you live, you learn. You live, you learn, you laugh, you cry. How dare you come in here and start saying slurs? Meow, 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 meow. Yeah, memoization. Isn't that a slur? What does it mean? Dropping the M word right away? Mm-hmm. Mm-hmm. It's a hard Z. Nah. I don't have time to look up what the word means. I'm in the middle of something. I'm really hungry, guys. I want to eat like 4 cookies all at once and then throw up. It's a technique to remember paths already taken so you don't take up time traveling down the same path. Thank you. Thank you, Savvy Devil. I'm sorry if you don't like my sense of humor, by the way. But yeah. I didn't mean to startle you. Man, I don't know. I didn't know what the word meant. So I made a joke. It was in poor taste. I was just joking. I was just joking. Okay. Oh, look at us. We're going places. Um, I don't know where, but we're going somewhere. Okay, let's also get rid of this information because we don't need it. Goodbye. You're done. You're deleted. Deleted. Erased. You're gone. Goodbye, buddy. Deleted. Deleted. Also, this we don't need you. Get out of here. Get out of here. You're so done. Out of here. Our base cases. What the frick we need those for? Okay. I'm gonna pretend that I knew what I was doing to begin with, and then move all of this over here because we need more space. Put it all the way in this corner. Okay, and now I would like to kind of like redraw this so that it makes sense. Um, let's get rid of these. And let's all collectively remember that it goes to 1, 2. Um, and we can do that by taking. I'm gonna take this. Go ahead and scoot it over to here. Okay. And then we're gonna take these and put them where they belong, which is right about here. And then we need more yellow arrows. So this goes to here and here. We're making magic happen. Look at this. This is the magic happening. Okay, the magic isn't happening yet. Let's make this shorter maybe. We gotta make it smaller and tighter so it'll fit. Right now, it doesn't really fit. Eat some second breakfast. I haven't had first breakfast. And then what if we just take this whole thing? Hear me out. Take this whole thing. Take this bad boy. And we go here. It looks really stupid, but it'll look better in a little bit. Let's just like tighten everything up. Oops. Let's. Oh. That's a lot of numbers. Sorry if I'm including you guys in crimes that you didn't want to be a part of, but no. Sometimes you just gotta take one for the team. Sometimes you just gotta be a team player. Move this. Move this over. You haven't eaten breakfast, isn't it 5:30? Um, I woke up when I started stream. I woke up around like, wait, and a half an hour. I woke up around 3 o'clock ish. But I took a shower. I did shower. I just didn't eat. I didn't eat this morning because the truth is I feel like I should punish myself for yesterday because I was such a bad kitty yesterday. I had a total like what do you call it? Like psychological meltdown on stream last night. And I do feel kind of guilty about that. But honestly, I'm hungry, so I think I'm gonna just I think instead of starving, I'm gonna just eat. But right now we have to do this tree. So let's do the tree first and then I eat. Yeah. Yeah. That's a good idea. Your punishment is having to eat a sandwich. Man, I want to squish the tree. I just squish it. Maybe instead of squishing it, what I should be doing is like giving it more room to breathe. This is a little bit better. I know it doesn't look better now, but just trust me, bros. Trust me, I think it'll be better in the end. Self-sabotage. Okay. Doomer moment. Are you plotting something? Pun intended. Yes, I'm up to no good. Um, that Lorax guy is gonna be so pissed when he sees what I'm doing to these trees. Okay. I feel like I'm also kind of procrastinating because like I don't want to type this out, but we'll just pretend. Um, yeah, we'll just pretend I'm being normal. Meow. Is it procrastinating, learning something by learning something else? Well, right now I'm not even really learning something. I'm just finicking with the Yeah, the thing that we drew yesterday. Like I'm making it like cleaner so I can read it because I couldn't read it. Which I guess maybe that's a good thing though. Thank you for the head pats. I do need them. I appreciate it. Meow meow meow. It was an inspirational stream. I feel like psychologists could definitely study my streams. Or like yeah, psychology students who want to learn what mental illness really looks like in the wild. Um, it's definitely wild. I'm not proud of it. Mm-mm. Meow meow. Rare non 3 a.m. stream. Meow Nang. How are you today? Meow. Imagine it's like your first time here, and then you're just like, what are these numbers? What are these numbers? Meow meow. Yeah, I'm gonna with with AI and like super intelligence, I'm kind of giving up on ever being able to make enough money to get myself out of like um student loan debt. I think I'll be able to pay off my like loan my yeah, my personal loans or whatever, like my credit card debt, but um oops, I didn't mean to delete that. Like, I think even people who are telling me things about like the job market, join the military, I can't join the military. I just told you I have a severe mental illness. First time here was about to ask what I'm looking at. It's a tree. It's a tree. Sui punitio. Meow. Empathize. Yeah. I'm not like very, very upset about it. More just like mildly um worried. Mildly worried. This goes to wait, I didn't finish this? Did I just give up? Did I just stop? I think I just stopped. Wait, what does 1 1 go to? Oh, this goes 1 0. This wait, that's not true. Did I mess up? I'm really confused. Let me give me a second. What did I do wrong here? 2 1. I definitely did something wrong. 1 2. Meow 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 meow. This should be a 2. Pretty sure this should be a 2. Ah, this is gonna be annoying to fix. Thank you, Lachuka. Self-diagnosed or officially recorded? Officially recorded many times. Many, many times. In multiple states. Okay. Make $20 off of 8 GB DDR4. Only 20? Do you mean $20,000? Damn, you're cooked. God. Thank you for making me laugh. That guy. You're so funny. So funny. You're so good. Okay, 2011. That's where that's. How did I do this so wrong? This is actually kind of embarrassing. Wait a minute. 4-1 doesn't go to 3-1 and 2-1. It goes to. I'm just gonna delete everything here because I just messed up. Um. First attempt in learning, further attempts in learning, final attempt in learning. Choice is yours. Thank you. I'm not giving up, by the way. I'm not giving up on like pursuing my goals. I'm giving up on the belief that pursuing my goals will necessarily get me somewhere. I don't think it'll really necessarily get me anywhere, but whatever. I can't read the future exactly. I tried. I tried using tarot cards, but um I think I think even to get the tarot cards to work for you, you have to believe them to some extent, and it could kind of tell that I was fraudulent. It could tell that I was a non-believer. That's a pig. Better than nothing. Meow, 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 meow. Meow, 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 meow. Okay. Um. Allergic to copium, unfortunately. Mm. Meow. That's why I don't have any copium. I don't have any copium left. It's all gone. It's gone. It's all gone. It's gone. It's gone. It's gone. 1, 2, 1. One, one, negative 4, 2, 1, 0, 0, 1. Ah! Welcome. Did they let you out of prison? What are you free from? What are you free from? Or meetings? Bet it was meetings. I have 3 hours. Okay, enjoy. I'm gonna redraw it. I think I need to redraw it. I think it's really bad. Man, I don't really want to though. Actually, let's not redraw it. Let's just do it in types like we planned to. I'm worried that I like okay, let me look at the problem again. Sorry, my tummy hurts too, so it's a little bit hard to think. Count change. Okay, where's the base case again? The when um when amount equals 0, then we get 1. When amount is less than 0, we get 0. And when kinds points equals 0, good. Okay. And then I also want to know the format is also PC amount, then kinds of points. Can I just use A and K? A B C A K, and then the math is that, let's see. Meow 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 meow. Okay, good luck. Thank you. Let's see. So every time we go left or right? Oh, I thought you guys could see it. Sorry. Every time we go mm, left, we need the same A and K minus 1. Every time we go right, we're going to have A minus F and then the same K. Let's see if that checks out. Let's only go left first. So we have A minus F and then K. So 11 minus F in this case is 50. So 11 minus 50, we get 39 and 5. Negative 14, 4. That's fine. Basically, actually, I don't really want to do the math, but as long as I should do the math, but I don't really want to, honestly. What is this 2? Um, 3, 3, 2, 2, 1, 1. Oops. Yeah, man. 2, 2, 2. This looks confusing. Let's move this over. The thing is, when I was drawing this, I didn't know how it was gonna end up. And I didn't know, like, yeah, I didn't know what I was doing, so I didn't, like, take the time to make it super clean because I was just kind of figuring it out as I went. I didn't even know if I was taking the right approach, honestly, but I just wanted to try it. Let's see, this is okay. This way. 2, 2, 2. Make this smaller. Meow, meow, meow. Yeah. One, 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 one. Okay. Now I want to make sure everything terminates before that I'm not missing anything. 654321000 11 10 9 8 7 6 5 4 3 2 1. That looks good. Okay, I think I fixed it. I fixed it. I'm gonna take a little break because I have a headache. And then when I come back, I'm gonna put this into a typist tree. And then we're gonna put this whole thing, we're gonna put this bad boy, this whole bad boy, we're gonna put it in this right here. Actually, let's see what it looks like now. Oh, it's broken. So I can't check what it looks like. Pretty sure. Okay, I'll be back in a little bit. Currently, write an algorithm to do it for you. That sounds like a fun project. Question though, I'm allowed to be a beginner, right? Allowed to be a beginner? Just checking if it's true, if that's the case. No? Stop bullying me. Oh, that guy. You're bullying me. Is that bored? I'm sorry if you're bored. Don't bully little cat girls online. It's not nice. Okay. I forgive you this time. I'll be right back. Meow 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 meow. Um, I made themed bao, like chicken dumpling. It took a while because my little niece was upset. Meow meow. Why is my computer like overheating? Ah ah. Sometimes I do. Alright, Ashipa. Blah, 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 blah. Mm. Wow, wow, wow. 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 Wow, 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 wow. Four has 11, 3, 14, 11, 3 has 11, 2, 1, 3, 11, 2 has 11, 1, and 6. And then 11, 1, 11, 10, 1. 11-0 emanates in 0. This is hurting my brain. I don't even understand what it is. Same. It's a tree. We're planting trees. Yeah, we're winning. We're definitely winning. Night night, Fisted. Meow meow meow. Okay, now to close all of this. This closes TP. This closes NP. Or am I wrong? No, this definitely closes NP. And 1, 2, 3. 1, 2. NP. VP opens here as V, another NP, and this here. Okay, I see how it's lined up. Okay. Wherever it okay. NP closes here, PP. It closes on the same area except for PP probably. Oh, this is gonna be tough. Let me think about this. Okay, actually maybe it's not as tough as I think it's gonna be. Um Let me just double check. This is it covers everything. NP is gonna be around this. VP is gonna be from VP to WUG. I think it's this one. It's NPs. Okay. Now I need to do the same thing with my code. Figure out where the trees branch and end and where the things are gonna be. Let's see. Meow, 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 meow. Oh my god. Okay. NJ. Oops. 15K, 15K. And then we want to go back to Hi, Dan. Thank you. Yeah. 11-1. 11-1 goes to 11-0 and 10-run. And well, around 11-0 and which is at the top, and it ends at yeah, this tree. B. I'm gonna go down like 30. Um, what did I miss here? Okay, now I need to figure out where 11-2 is supposed to end. 11-2 should wrap around this 6261 is 11-2 gets 11-1 to one side. Actually, let's think about but let's just try. Let's see. 30, and then do it. What am I doing? Let's see. The now meow. 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 Maybe if I go in here, like close this, go to the end of the line, then close this one, close, close this. Also, I think I can't. 6-2 goes around 6-1 and 1. So 6 goes around 1, 2, which ends on. Or 1-2 goes to 1-1-4-2. Wait a minute. What did I do wrong here? Let me think. 'You had what right the first time? I don't know what you mean, sorry. I don't know what you mean. 4-2. Alright. Be closing this. 1-1 should be closed. 1. Oops. Um, 1 1 0 and 1 and then 1 2. Okay, and then 6 come after that. I think this should close 6. E. Enough lines. um. Oh wait, I can't read. It's not. Oops. A 6-2 is closed. Does that mean what about 11? I think after that should be 11. Wait, actually, yeah, let me think. All the way down to I thought I closed that already, but I don't know. Oh no, I closed 11-1. 11-2. Needs to wrap around the full 11-1 branch, and it does, but it needs to wrap around the full 6 where I was before. So let's go to the down. Go back up. 27. And then under here, perhaps. Let me think about this. Where's 1-3 coming from? 1-3 is part of 11-3, which includes 11-2. That should be correct. And then 11-3 goes around all of 1-3. 11-3 ends at 0, 9-3, 9-3, 1-3, 11-3, 1-3, 1-2, 1-1-1-0, and then 9-3. So, kind of. Wait, let's go back in here. 1, 2. Let me think about this. I think I did this wrong. Maybe not so. 1-2, 1-3, and then around 1-3, 11-3. There should be these for 11-4. This should be 11-5. Let's see. I need to see the whole thing. I need to see the whole make it. That looks, oh, that looks, I don't want to get excited, but what if it works? I don't want to get too excited. Yeah, yeah. This tree is, I'm gonna try to make one of these for this, for this problem here. If this function. This function for the amount 11. Okay, let's see if it works. Oh, I didn't get an error. Oh, I'm scared. I'm scared. Oh, okay. We have a tree, boys. It's like too big. It's like way too big. Wait. Um, it's too big, but it is a tree. Well, shit. I didn't think that it would be I didn't think it would be too big. It's like falling off the edge of the paper. Excuse me. Yeah. But at least it's a tree. Um, yeah, let's see. Huh. Well, um, awkward. I wanted it to look pretty like that guy, Tim. On this guy, Tim, where is he? Let's see. I have not seen. I see. One. Looks nice. Yeah, it needs some fixing. No, actually not. There's one I saw that I really liked. Ben and oh, this one. So here's the solution. A little bit hard to see. I don't know what they. Actually, I do know what they use. They use something called Graph Viz, and I don't have that. But I could get it, I guess. I could try it with Graph Viz. I thought I could. I thought I could get away with doing it in type. But anyway, let's see how much it matches. Yeah, I didn't include the CC. I took the CC out because I thought I was being clever. But now that I look at his, I think his looks cleaner, much cleaner with having the what do you call it? The function name in there and having it all in parentheses. But 11.5 should go to negative 39.5. Also, um he didn't like resolve it to the number, so he doesn't have like all the zeros and ones, but he did highlight the places where there's, yeah, like this tree from 11.3, and then this one from 11.2, and this one also from 11.2, and then this one from 11.1. Okay. Meow, meow, meow. What am I trying to accomplish? I'm doing the highlighted question here. Draw the tree illustrating the process generated by the count change procedure in making change for 11 cents. And then I have to answer these questions. What are the orders of growth of the space and number of steps used by the process? But I don't know. Anyway, I wanted to see if I could like I could draw the tree, and that's what I did at first. I drew it using like by hand, just so I basically to prove that I understand what the function is doing, how the recursion is working, how the recursive process is working, the tree recursion. But then after I did it by hand, I'm like, okay, I want to do it by code, and I tried with this. It doesn't look. It's not great though. I think it needs to be fixed. But for now, honestly, I kind of do wanna. I need a break. Um, yeah, I need a little break. Yeah, I need to use the litter box. Yeah, hopefully. Yeah, I should finish the problem completely though, so I should answer that question. Let's see. Um, I don't know how to answer it yet, but when I get back, I'll try to answer. Ah, okay. Ah, get back. Yeah. Yeah. I didn't egg on stream, but I did egg on the toilet. I did egg on the toilet. I did egg game a little bit. I got a new pet on my main account, but I'm not sure. I haven't played the alt account yet today. So I find this. Mm, thank you. Thank you. Meow. Meow meow meow. Meow meow meow. I did wash my hands because the toilet paper was really flimsy. I got a Kit Kat! Yay! That's really good. I got a Kit Kat. Yay! Kit Kat. Yay! Kit Kat. Yay! Wait, that's really good. That's really, really good. That'll come in handy later. Let's see. Thank you. Yeah, I'm actually uh, surprised because I kinda low key got one of the best pets in the game on my main account, but I was like in a kind of bad mood, so I don't know how to react. Yeah, this is the egg game. It's called Void Pet Dungeons, but I don't recommend it because I want to quit, but I'm too addicted. So I don't really want to like I don't want to do this to other people. I don't want to make you guys suffer like I suffer. Every day I have it's like crack. I have the urge to get on it and like collect pets and battle. Man, this guy doesn't want to give me the damn scarf, and I don't have enough gems to fight him again. Man. Okay. It's a mobile game. That's another reason why I don't recommend it. Imagine playing mobile games? That's insane. That's insanity. But I'm addicted. What do I do? Hmm. I can't stop. I can't quit. I don't know what to do. I just do my dailies and call it what it is. Let's see. Who can I use things on? Glee is useless. Lonely is useless. Pain, desperate, grumpy, useless. Useless abandonment. I could, yeah. Let's go ahead and just spend some of my coins. You can whatever. Oh god, oh god, oh god. I forgot to put on music so I can hear too much background noise. Put on rain, drown it out. Meow, 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 meow. I feel very, 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 very sad. Sad, 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 sad. Sad. Okay, though. Alt T. Don't need anxious, don't need joy. Joy could be useful to have. Let's go ahead and give for joy. Come on. Sad, sad, sad. Wonder I like, but isn't really good. Sanctimony is bad. I kind of probably need conviction. In fact, I think I need conviction right now. But I don't. Yeah. I don't have enough experience points to level him as much as I need to. Cringe can be evolved. Cringe might be good later. And spite. Meow, 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 meow. That guy, do I know you from somewhere? Are you Ray on an alt account? Or is this your first time here? I feel like you're gonna say something upsetting. What do I do? What do I do again? Oh yeah. We try conviction even though it's only level 76. 35. This is not gonna work out well. Whatever, we try it. Drifted here yesterday. I see. Oh no, I see. Uh-oh. 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 We're so dead meat. Meow. 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 You eepy? I'm a little eepy too, but I can't sleep. I have to work more. Work more. Work more. Work more. Meow. Meow. Is he gonna one shot this little buddy? I should be way happier, but I'm not. Hi, the consultant. Mm. What's up? What's up? Try to get a little bit comfier. Put this to the side. And then. I don't really understand. Ah. So, I don't know. I thought the little bean would have died already, Frank Custer. But, um, this is conviction. He's a metal tank that, after taking damage, gains a crit, and his crit hits gain him a shield. The other thing too is, so like right now he has an elemental advantage because it's a metal, he's a metal tank against wood boss, and yeah, metal is strong against wood. So even though he's only level 75, he's really hanging in there a lot more than my level like 110 tank or 100 tank. So I should have used him earlier, but I was being stubborn because oh yeah, I did feel like leveling him. Got destroyed at my last math Olympiad after months of preparation. Head pats. Mm. Meow. Meow, meow, meow. Meow, meow, meow. Oh. Ah. Well, we finally lost, but I think we got closer. Not a math girl, I'm a dumb girl. Hmm. Wow, 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 wow. Wow, 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 wow. Flex, flex, flex. I don't understand. I don't understand. Oh, we almost got him. Probably in a little bit. We get him. I feel upset. I feel very sad today. It says it all over. It's in the title of the stream. It's the pinned comment. It's going better than Friday. What happened on Friday? Are you talking about like running and stuff? Or what? Better than one. I'm sad because I feel like no, not because I feel like wait, can't think. I feel sad because I'm bad at everything. I'm gonna keep being bad probably for a long time because it takes time to get good at anything. I think the world is changing fast and I don't know how to get out of debt. I think the economy for like if you're already wealthy or you don't have a lot of debt, you're probably fine. But you ever it feels like basically it feels like the goalpost is moving as I work towards a goal. Yeah, doomer maxing a little bit, but I'm not giving up. I think doomer maxing is saying like there's no point, so I'm just gonna rot. I'm gonna like brain rot and like give up. I haven't given up. I'm just sad about my situation. That's, you know, but whatever. Yeah, whatever. I'm I don't know the future. Maybe the future looks really really good and I'll be surprised if good things happen. But um yeah, I can't help but feel like yeah, I'm just really behind and I don't know how to fix it. The act of negative thinking is slow plague on the mind. Yeah, that's true. I agree. Um I definitely agree, but I also think that some people are naturally positive thinkers, or at least, um, yeah, have a habit of positive thinking. So, um, I can try to think more positively, but authenticity matters to me to some degree as well. So I don't want to pretend to be thinking positive when I don't really feel that way. But yeah, maybe it's better to think nothing than to think negatively. So I'll try to turn my brain off and just focus on the math. Let's see. I don't understand how to count the steps really. What does it mean to count steps versus wait. Yeah, I feel like I don't understand what it means to count the steps. I thought I knew. Um, yeah, I don't think I understand. Hi, kiss. Hi, kitty. Hard to be positive. Mm. Mm. If things look or feel bad, you perceive it that way without a filter. Meow, meow, meow. Can't be sad if you're locked in. I gotta get more locked in. I'm trying to get locked into this problem, but I don't understand. I don't. What is considered a step? If you look at the explanation, there's no explanation of what is considered a step. We could start with an atomic step. It has a summation and an assignment. Um, this has n atomic steps as print will be run n times. The number of atomic steps are n squared. For I in range, print I. For I in range and print for j in range, print j. If n was 5, the first iteration would be 5, and the second 4, the third 3. I don't understand. As we can form a general formula, number of steps would be n times 2 plus 1 over n plus 1. I don't understand that. Order of growth steps is an approximation of how the number of steps increase. And the reason I say it's approximation, we only want how it grows if the number of steps increases linearly or quadratically or logarithmically. We take the degree of our formula. Yeah, let's take hi. I'm not a doctor. I'm not a nurse. I'm a fraud. Thank you for wishing me luck. You're sweet. What a sweetie. I don't understand at all. I don't understand the math of this at all. I don't understand. I don't know. Let's ask perplexity because I feel really dumb. Ask perplexity. Why not? Ha 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 ha. What do you want to know? I want to know what I want to know. I want to know what I want to know. Okay, let's see. How do you... Okay, actually, let's start. I'm confused about orders of growth. I'm working on SICP 1.14 and I don't understand what they mean really by the orders of growth of space and steps. Both from a conceptual standpoint and also how to solve it. Can you explain this to me like I'm 10, please? Keep the explanation reasonably brief, succinct, and how do you spell that word? Oh, I missed it. See, succinct and what else? Do not use too many different examples. If it helps, you can try to explain using um factorial recursive process iterative process meow. After reading this exercise, all I could think of is meow, just meow. Yeah, right? Meow. Meow. Okay, order of growth are just a way to talk about how fast work and memory blow up when the input gets bigger. Think of a function like factorial that takes a number n. As n gets bigger, two things matter: steps, which is time, how many little actions the computer does roughly, space, which is memory, how many things it has to remember at once while it's working. This makes sense. Why couldn't they just say it like that in the book? Wait a minute. Literally, they could have just said that in the book, man. This makes so much sense. Okay, God damn it. I'm so upset right now. Because they use factorial as an example, but they use more difficult words. I didn't understand what they were trying to say, man. Because if we look, um, the time, how many actions the computer does roughly, um, for the recursive process is all of this, um, and how many things it has to remember, the space. I'm not sure. I'm not sure if it's really. I guess it's while it's working, it has to remember. Um, I guess it has to remember everything in that up to that step. Same reason they use meme functional language. Hardly anyone uses it for real. Um, academia in a nutshell. um, and then with the factorial, you have, you know, similar number of steps, but how many things it has to remember at once is significantly less because it just needs to remember the three numbers instead of like all of the things from this step. Now let's double check. I think that's what it said, something like that, but it didn't say it in English. It said it in Mandarin. We're gonna read it in Mandarin. Where is it? Where are you hiding? Show yourself. Okay. Um, 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 For instance, with the linear recursive process for computing factorial, the number of steps grows proportionally to the input n. Thus, the steps required for this process grows as theta of n. We saw that the space required grows. We also saw that the space required grows as theta of n. Yes, exactly. So the space has to grow. It's not the same for each step in the linear recursive because first you need factorial 6 and then you need 6 times factorial 5 and then you need 6 times 5 times factorial 4, so it gets bigger and bigger as like up to n. But for the iterative factorial, the number of steps is the same, but the space is constant. That's what I was confused about where they had 1. The space is constant because no matter what step you're on, it only requires the same amount of memory, right? Space and time complexity. The tree recursive Fibonacci computation, this is the one I want to look at now, requires phi to the n steps and space is n. Okay, so let's look at that. Fibonacci. Um, So if we said steps is how many little actions the computer does. That's like um yeah, all of these. And then how many things it remembers at once. I think it's I don't know, can you see it with just um it's okay. I'm not explaining well. I'm trying to figure it out as I go too. I'm wondering how okay. How do we know pi is 1.618? 1.618 to the fifth. To yeah, is 11. Or a little bit over 11. I wonder what that even means. Like, what does that mean? What does that actually mean? I guess if it was 1, um, oh, I guess it's not 11. This is just one example. So it means that at Fibonacci 0, the steps are phi to the 0, which is 1 step. At Fibonacci 1, the steps increase from 1 to a little bit over 1. And then at Fibonacci 2, it increases a little bit more and more and more. Let's say 100. Oh, that's too big. Do 10. 122. Okay. It increases exponentially in a way. Yeah, it actually that is powerful. It increases really, really, really quickly, right? Because it's not just a doubling. It's like it's growing exponentially by n. Anyway, that's for the time. But they said that the space, how many things to remember, the memory for Fibonacci was only n. So what are they? So that's how many things it has to remember at once while it's working. Oh, okay. Oh, it kind of makes sense a little bit. I think it's because with Fibonacci, it doesn't have to, like, if you're doing Fibonacci 5, meow, meow, meow. Why is it n? Why is the space n? I don't know. Why is the memory n? How many things it has to remember? 5 things? It has to remember each value, each Fibonacci. Okay, thank you, Western Tanuki. Oh, Tanuki! Cute! Ah, cute! I have a Tanuki model hiding somewhere. Anyway, okay. Order of growth says when n is huge, do steps grow like n? Like n squared? Like some constant that doesn't grow at all? And writes that as theta of n, theta of n squared, theta of 1, etc. Pick a size. What is n? For SICP problems, n is usually the size of the input. For factorial, n is the number you are taking the factorial of. For count change, n is the amount of money to change, how big the amount is. You do not count exact steps like 37 or 105. You only care about how the count changes when n doubles or triples. Factorial, recursive versus iterative. Actually, okay, getting closer to something. Chicken jockey? No. Recursive solutions tend to be n squared or n log instead of n. For iterative solutions, there are exceptions, but that generally follows. Ah. Hmm. What is n log of n? Is that like a lot? Is that like a lot? A lot? I forgot logarithm. Or does it like taper? What does a log even look like? Wait, I'm gonna just look it up. Yeah, yeah, it's funny. Yeah, look at a graph for log n. Exactly. I know. That's what I was thinking. I'm just sometimes my words come before my brain finish working. Oh, meow, 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 meow. Man, I'm so that's also why I'm taking my time on this one, because I know the next problem I'm pretty sure goes into trigonometry, and I'm gonna just open up a whole can of worms of worms that I tried to forget years ago. It's the inverse of an exponent. It grows slower as it gets bigger. Yeah, I don't know why I didn't remember that. Um, let's see. Because I'm dumb, I guess, but for anyone who's curious, I'm taking a look at this picture here. Um, 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 So one is like constant. Well, yeah, same number of operations no matter the data size. Log, I haven't seen that graph for ages. Mm, meow, meow, meow. How are you gaming, gaming? And then if it linearly scales with n, and then if it's exponential. Oh, okay, yeah, it's even. So the Fibonacci has um uh what is it? Steps. Is it steps or memory? I think it's steps that are on this scale. How many? Yeah, it takes a long time. Um, I don't think I passed a single log test when I was in school. I mean, it's the kind of thing you have to just do it a lot and then you remember it. But then I feel like if I don't do it for a while, it's just gone. It's just out of my brain. It just disappears. Oh, time complexity. Oh God. Oh no. Oh, what does this mean? Okay, it's breaking in half time. Oh, okay. Well, wait. Ah. Oh, I see what live type is saying, kind of, right? So recursive solutions. I could see, like, because I can kind of see the tree. But anyway, I still don't really understand, but it looks interesting. I don't like full, like, it hasn't all clicked, but I think we're getting closer to something. This one looks pretty cool. Look at this graph. Look how interesting this is. A log that base 2 n. Interesting. Yeah, I don't know what this is either, but I'm gonna, I feel like this is gonna be really important. Man, this one is even more confusing. I'm trying to look for one that I like. CPU operations. You can have like, just like, it probably gets so big. It probably gets really big. Anyway, I'll leave it alone. Big O. Oh, 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 oh. I'm gonna close this now. So my other point with this though is do I have to be able to prove love your funny words, Magic Man? Yeah. Do I have to be able to prove that I know for a fact like what is there like a shorthand? Can I just plug in different ends and see how n changes? Can I just plug in different ends and then don't understand? Yeah, I don't know actually, but that won't work really. Um, yeah, I don't understand it. You can start that way. You don't have to know. You have to know how to solve problems where you can fit the entire data set into memory versus not. Got you. Sort of like how to recognize what it's gonna do instead of understanding exactly what it does. Um, like what Perplexity said. How fast work and memory blow up so that like looking at some solution, some function or whatever, I could see if it's like dangerous. The proof requires formal induction. What are you talking about? I was just saying the word. I didn't mean it like that. I didn't mean like prove it like that. I didn't mean I'm not doing that. No, that's not what I meant. I just meant like to answer this question. What are the orders? How do I answer this? I think I thought I knew and I think I know even less now. Okay, let's see. Compute factorial n. This calls itself on n minus 1, n minus 2, 0. That's about n calls. So steps grow like theta of n each call waits for the one below it to finish, so calls pile up in a chain of length n. Memory you must keep at once is also theta n. I don't know what you guys are trying to say. I don't really understand what you're trying to say or insinuate. Wah 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 wah. Mm. It runs from 1 to n. Each step passes new numbers into one active call. It doesn't stack up calls. The computer just keeps a few variables. No matter how big n is, the space is theta for one constant. Imagine steps as how many times you clap your hands to finish the job. Imagine space is how many books you must keep open on your desk at the same time while doing it. Order of growth ignores small details like whether it's 3n or 5n plus 10 and just says this grows like n or like n squared or doesn't grow at all. Look at the recursion tree. Ask, how tall is it? Base. How many total calls are there? Steps. Then express those in theta form as the amount increases. The memory requirement is higher with the recursive solutions. Okay. Um 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 ah wah 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 wah. I gotta fix the tree, but I don't feel like fixing the tree right now. So I'm not gonna fix it right now. I don't want to fix the tree right now. But pretend this is my tree, okay? This is a tree. If this is a tree, time and space or memory. Meow 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 meow. I'm in trouble. I'm in trouble. I'm in trouble. No, I don't understand. Many people. Sorry if it's frustrating to watch me again, cause like I'm a newbie, so it might be frustrating when I get kind of stuck, but fine, it's fine. I'm just not sure if I did this wrong or if I'm misunderstanding. Wow, 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 wow. I don't understand how to figure it out, is what I think. I don't think you should dread it. It's nothing. You don't have to be afraid or dread it. But yeah, it's okay to not understand a little bit. Mhm. Mhm. Mm. Meow meow meow. I don't understand how to determine it. But I'm gonna. Very simple terms. What steps would you take to determine uh the order of growth of space and number for vectors for for a proper ah decide what n is. So n is amount of change. Mhm. How many times the body runs. I don't know what that means, man. What the fuck is it? If n, okay, let's take a look. If n gets bigger, how many times do we repeat the main work? For simple loop, the body runs about n. For a loop inside a loop, you get n squared. You always do the same operation, no matter what n is. If n gets bigger, how many times do you repeat the main work? So if n is 1, one, 1, 5, 1. And then do one step. Then if it was 2, it would be 2, 5, which is negative, so that stops. And this is negative, so that stops. 2 minus 50, 2 minus 25, 2 minus 10 is negative, 2 minus 5 is negative, 2 minus 1 here. I would think of it as fewer coins. Attempt to start with the biggest denomination and move down until we get the denomination that can go into. Yeah, that's what I did. That's exactly what I did. I drew this tree. I drew this tree. This is what I did. Yeah, that's exactly what I did. I started because we're doing for the count of 11 cents. So I started with, okay, half dollars and then quarters and then dimes and then nickels and pennies, right? That part I kind of get. What I don't get though is from count change 11 to count change 60 or to count change 5. Like between, like as n changes, as the amount of coins we have changes, I don't understand the like how drastically the tree changes, or it maybe not even the tree, just like I'm trying to figure out yeah, how to calculate to determine this relationship. It says that first count how many times the body runs. So I'm wondering if it's like basically how many times the recursion has to go. Memory space. I'll be in working. Meow, 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 meow. Hi, 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 hi. Um, we, 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 we. Um, I think it's n times, but I'm not true or if I'm making it up. Right? So, um, meow, 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 meow. If we have 0, we just get 0. We just get 1. If we have 1, that becomes meow, meow. Meow, 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 meow. 1, 4, and then negative 49. I don't know how to write this one. I'm just gonna solve it. It goes to 0. And then 1, 4 will go to 1, 3, and um 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 a 1 minus 25, which is negative, so that would be 0. And then a 2 and that's 3, which is a dime, and that's 0. A 1, 0, and then 1, 0, 1. And then if we have 2 cents, 4, 2, 3, 2, 1. Oh, and then 2, 1 would lead to 2. A, which is 2, minus a penny, 1, and K, meow, 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 meow. And then it'll start expanding. Okay, let's see. Did we get... Actually, this doesn't make any sense to 2, 0, because it's 0, that's 1. I think I did something wrong. What if you try making a graph which x is n and y is the number of steps it took to get the solution, then compare it to the order of growth graph? No, Frank Hester, that would work, but my question is, how do I figure out the number of steps? So I understand, like, n grows, but I can't graph it. I can't graph, I can't graph the number of steps, because my issue isn't like, it's not like a, you know what I mean, like, if I did do, if I knew meow, what constitutes a step is something like the number of uh, loops, number of times it goes through a loop for n. The structure are generally log n or n log n. Three structures. Yeah, so live type, I believe you. I believe you. But my question isn't like, my question isn't just, is it log n or is it n log n? My question is, how do you find out? How do you calculate? How do you determine? Instead of just going on the gut or going on the like rule of like, okay, tree structures usually go by this. Like there's like an actual answer to some extent, right? Or not even an actual answer, because like, again, the number of steps is sort of what do you call it? Like, it can kind of be contested. It might not be like a perfect whatever, but there will be a trend. There will be like a trend, and I'm trying to figure out. Anyway, I'd be quiet now. I'd be quiet. Let's just let me think a little bit here. I'm looking at this. So, um, when it's when we have 2 and 1, we got 2, 0, and then 2 minus f, which is 1 and 1. Okay, and then we get 1, 2, wait, 2, 0 is literally just 1, and 1, 1 will be 1, 0, and a is 1 minus f, 0, 1, and that ends up being 1. When amount is 0, 1, when kind is 0, 0, 1, 0, 1. My brain hurts. Time to lock in harder. I think so too. Um, I think I definitely did something wrong. Why am I so stupid? Why am I so stupid? Did something wrong. Oh, I see what I did wrong. Okay. 2, 0, 1, 1. Actually, I don't see it, but I see it. Let's see. 2, 1 becomes 2, 0, 1, 1. For 2, 0, that's actually 0. That's where I went wrong. 1, 1 will be 1, 0, 0, 1. Then we get 0, and then we get 1, 0, 0, and then 0, 1 is 1. So basically, birds, 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 birds. So if you know how coins work, you can kind of sort of start to figure out how things are going to change, right? So like if we're counting 1 penny or 2 or 1 cent or 2 cents or 3 cents or 4 cents, there's only one way to do each of those things, because you either have 1 penny or you don't, or you have 2 pennies or you don't, right? But once you get to 5 cents, there are 2 answers. So that's basically what I was trying to figure out. So at 0 to 1, at 0 to 5, 0 to 4, we'll say 0 to 4, there's one step, or one, not step, that's not the, I don't want to use step. One like method, right? And then once we hit 5, we get 2. 5, 6, 7, 8. 5 to 9, we have 2 ways, 2 methods. Then we hit a dime. So we can, when we have dimes, we can have 1 dime, we can have 2 nickels, we can have 1 nickel and pennies, or we can have pennies. So that's 4 methods. And then at 15 cents, we can have a dime and a nickel. We can have 3 nickels. We can have 2 nickels and pennies. We can have 1 nickels and pennies. And then we can have the rest, which is all pennies, which is 5 methods. And then at 20, I think it goes up by 1, right? Or actually, no. I don't want to guess. 2 dimes. 1 dime and 2 nickels. 1 dime. 1 nickel and pennies. 4 nickels. 3 nickels and pennies. 2 nickels and pennies. 1 nickel and pennies. So there's like 8 methods. So what I'm trying to figure out is what the heck is this? Like going from 1 to 2 to 4 to 5 to 8. Like, is this logarithmic? Steps n log step n plus 1 to the n. Drew, how did you get that? How did you figure that out? How did you know that? Needs iterative function. 15 has 6. Okay, 15. See. Dime and nickel. Oh, dime and pennies. I didn't include dime and yeah. So I'm not even correct. So let's write it down. Let me write it down. So we just have pennies only. We could have nickels and nickels or pennies. My brain hurts. Actually, this is really wrong. This is really wrong. 5 is 2 methods. Nickels or pennies. 9 can be, it can be nickels and pennies, or it can just be pennies. And then 10 can be dime, 2 nickels, nickels and pennies, pennies. And then I think logarithm is going to be navigating the tree, or going down one branch in this case. Generating all possibilities for ways to count change should be something bigger. I'm sorry. I really don't understand what chat is telling me. I don't understand what that means. I think logarithmic is going to be navigating the tree or going down one branch in this case. Generating all possibilities for ways to count change should be something bigger. Okay, got you. I was just trying to, okay, let's see. And then you have a dime, well, dime and pennies. We could have 3 nickels. We could have 2 nickels and pennies. We have 1 nickel and pennies. Or we could just have pennies. 1, 2, 3, 4, 5. Anyway. Let me see something. Meow, meow, meow. Meow, 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 meow. Meow, 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 meow. I think I'm barking up the wrong tree. Do you get it? Do you get it? Haha, I made a pun. I think I'm barking up the wrong tree. Since every call of CC calls CC one more time until eventually reaching 01 base case, it has the time complexity of 0. Oh no, not 0. That's theta. Of theta n. How did I prove that? Whatever. I don't know. I don't know if I care anymore. To be really honest with you. This is not the right way to go about it. Like, I shouldn't be so flippant. I went the wrong way. Meow, meow, meow. Tummy hurts, tummy hurts, tummy hurts. Count how deep you go for space. How many things are stored at once at the peak? You reuse the same few variables, and that's one. For linear recursion, it's chain. Tree shape, look at the height of the tree. Estimate this. Look at the height of keep only the dominant term. Once you have an expression for steps, like, and I don't have an expression for the dominant steps. Wah 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 wah. One more to 40? No, no, everybody! This is where everybody leaves, so we go back down to 0. We go back down to 0. Thank you, kitty pillar. Meowing up the wrong tree. Count the loop iteration recursive calls with main formula. Let me see. Here's a solution, but I just don't understand it, and I wanted to understand. That's all. I just wanted to understand it. Um. Goodbye, 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 bye, bye, bye. Here it says, since this is a recursive process, the orders of growth of space will be proportional to the depth of the tree. But isn't that not true? I'm so confused. Or am I confusing space and steps? And then there's all this math I don't understand. And I think this person is just making up the math. But they're probably not. The growth of the number of steps is n to the fifth. That's fake. What happened to this morning love talk of it? Last night I had such a crash out that the vid had to be nuked. But don't worry, I have so many stalkers um who download my VODs, so it's not gone forever. I'll put it on Patreon. I'll put it on Patreon, and some of the stalkers have a backup copy too. But yeah, I had a really bad crash out. It was embarrassing. It's always embarrassing. So I'm gonna say that the orders of growth of the number of steps is, wait, the heck? The orders of growth of the number of steps is fake news from the biased liberal media. It does not. This. I don't want to. I don't want to move on, but I feel like the more that I read, the stupider I get. The more that I read, the stupider I get. Maybe I could find a. No, it's not clippers, Lechuga. There's people who don't clip me, but they save all of my VODs. They don't even make clips. They want to have like encyclopedia knowledge of everything I do. They just keep it on storage. There's like at least 3. Anyway, it's good though, cause like one time I forgot to save a VOD and someone actually did just randomly had a copy. They're in your walls. They're my government agents. Grade up, grade up. Wait, wait. Meow, 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 meow. The other thing too is there's like all these solutions on the internet, but I don't know which ones are even real. I feel like these solutions are made up. The rate of growth for 5 coins. The rate the growth rate for the number of steps with 5 coins would be n to the fifth because the 5 coins? Is that why? That sounds. I wanna cry. Can I cry? I'm gonna try reading Tim's blog because I still don't understand this. Here is the order of growth for count change with an amount A. Leaves colored in red return 0. Leaves colored in blue return 1. I've also shortened the diagram since otherwise it becomes too large to fit on the screen. That's what happened to me. That's exactly what happened to my diagram. Look, I show you guys. Mine is too big, it doesn't fit on the screen. It gets cut off. It gets cut off, right? So it's so bad. I should have been smart like this guy. Mine doesn't fit. That's what she said. I mean that's what that's what he said. That's what they said. That's what Kitty Kitten said. Um, anyway. Anyway. Um, um, anytime only one type of coin is left over, it is instantly counted as evaluating to 1. This makes sense as you only have one way to make change if all you have is 1 cent coin. So that's like a life hack right here. Like there's only one way to make change out of pennies. Think Jeebus. Okay. Let us analyze. Oh, wait. I think I'm understanding mathematics. Give me a second. Ah, ah, ah. How many ways? Someone told me this in the chat. I think it was Lent 2, and I didn't listen. I wasn't listening because I didn't understand what you meant. I think that's what I should do and then work backwards. So, how many ways can you make, like, 99 cents using nickels, or let's say, let's use 50 cents. 50 cents using nickels, right? You can have 5, you can have 10 nickels. I don't know where to write this down. You can have 10 nickels. You could have 9, 8, 7, 6, 5, 4, 3, 2, 1. Because all you have is nickels and pennies in that case. So what's that number? 5. Wait. In that case, 1, 10, and then you add dimes, and you can do 5, 4. Oh, there's so many. Brain hurt. So many. Actually, I think I'm a retard, guys. Wait a minute. I think I'm actually retarded. Wait. I already knew that, but wait. Hear me out. Um, Wait, actually I don't want to do this here. Let's get out of here. Let's go back in. 1.4. Let's just go in this version for now. And then, oops, oops, oops. Wait, I think I just realized something because, like, boys, I don't have to do this by, I don't have to do this by, like, hand. I could just change, can't I just change the amount? And, like, dude, oh god, my brain hurts thinking about it. Okay, we're gonna make a screen, and we're gonna call it meow. And then we're gonna call the window 0. Then we're gonna make chicken, and then yeah. It did escalate. I am so dumb. Wait, I think I see a path forward that doesn't involve me handwriting a lot of things or counting on my fingers. Wait a minute. Wait a minute. Wait a minute. Wait a minute. Let's see. I need to. Okay, we put that in there. Let's see. Count, change. Let's use 50. Ah, why does it have to be exactly 50? That confuses me. Count, change, 40, 50, 100, I don't know. 292. Okay. What if there's 292 ways if we can use half dollars? But what if we can only use up to quarters? Count, change. I feel like this is not gonna help, but maybe it does. It's still 292. Oh wait, I forgot to update that. My bad. My bad. My bad. Count, change, 100. Not a 242. Okay? We lost like 50 ways. Wait. And now if it's 3 with dimes, and then it was 242. Count, change, 100. 121. Okay. I should have been writing that down. Basically, I'm trying to figure out what the relationship is, but I don't know if this is gonna help. Maybe it doesn't. There's 292, 242, 121. Um, 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 62. Meow, meow. Count, change. 21. And then it should just be 1, right? Or 1? Wait. Okay. Hum, 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 hum. Let's get married? Why are we getting married? 134. Trying to cheat. I'm trying to cheat, but I don't think it works. Wait. Forward 5. Space 4. 20J. My brain is. Oh, wait. No, my brain is still damaged. Why is it the same? Why is it the same? Why, 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 why? Why, 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 why? Why, 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 why? Why? Uh, okay. I'm stupid. That's can't read this one. 24. Okay. Forward to 3. Replace it with 4. Run it again. Go down to 20J. Run it again. Go down 4. 121. Go back to row 24. 24K. Then forward 4. Place 2. Run it again. And then I want to go to 20. Run this again. And then I want to go down to 5. And go to the next line. And there should be 1. Oh. Does anybody see a relationship between these numbers? Is there a relationship there? I think I'm barking up the wrong tree again. Whatever. 20J. Oops. I didn't mean to do that. I meant the opposite. 20K. 20K. Ah! Forward 2. Place 5. Someone said something about a graph earlier. I was trying to think of like. Given. Basically, I'm looking for like a curve. What are you trying to solve? I don't know. Don't know. I'm trying to figure out the order of grows. Trying to answer an algorithm. No, I'm trying to figure out I'm trying to figure out how do I know for sure, like, what the order of growth is. And I think I'm just too stupid to see it. Or maybe, yeah, yeah, I'm just really, really dumb. Um, meow, meow, meow. The argument I wanted to make, though, is that, like, what was the argument I was trying to make? If through the count for the count change uh function procedure for the count change procedure, if the CC, like the recursive procedure inside, is only dealing with one kind of coin, if it's only dealing with one coin, so pennies only, actually pennies are one, then the what is it, the space, maybe? I don't know. Either something about the order of growth is like constant. No matter how much you change n, you're always just gonna get one because there's only one way. Reference 122. Yeah, I went there already. Yeah, it's just this, it's this. This is it. This is the function. I highlighted it. That's a function from 1.2.2. Anyway, the reason why I'm wondering about this is because I think I'm dumb. Meow, 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 meow. Um, 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 um. Actually, okay. The other way of the way that I was trying to think about it too is sort of like as n changes. Oops. What happens as n changes, as n grows bigger? What happens to the function, right? Or like what happens to the answer? Um, wow, wow, wow. Wow, 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 wow. Wow, 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 wow. Tummy hurts. My tummy hurts. How is theta n affected by count change? That's what I don't understand. That's what I actually don't understand. And I was trying to understand, but I don't know how to approach it. But, um, um, 1 second. Mm. Oh, duh. 13, 13. Um, yeah, it gets bigger, Lechuga. It gets bigger, but my question is, so like it can get bigger linearly, it can get bigger like exponentially, it can get bigger logarithmically, and I don't understand yet how you figure out which kind of growth it is other than from someone saying like if it's a tree, it's usually this, or if it's not a tree, then it's usually not this. But honestly, I won't stay here too long. I'm just curious, that's all. I will try to move on to something else soon. No, I think it's like cuz they're pulling it from the sorry, why is my voice cracking? They pull it from somewhere. It's not like it's not like they're just making it up, right? Like someone knows a definitive answer. So I want to know, how do you get the answer? How do you figure that out? It doesn't seem like um even Perplexity says roughly, told me to like roughly estimate what happened to N, or what happened. I don't know, whatever. Words. Forward 3 again. The bottom. Meow, 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 meow. meow, 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 meow. Wow, wow, wow. Wow, wow. Is there a way in Vim to take 3 lines? There definitely is. I want to take 5 lines and put them all together. Wait. How to wait in Vim? How do you combine 3? Wait, multiplying 1 line with space. Join command. No, that's not what I mean. Wait. No, 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 wait. Joins the current line next to its spaces. Really? Uppercase J to join the current line with the next? Wait, 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 wait. Okay. Wait, wait, wait. Yay! This is why I like Vim. Yay! 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 Anyway, um, bloop 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 bloop. What does this mean? Yay! So which tree am I barking up against right now that I'm confused about? What I'm trying to say is if you take 100, if you have 100 cents, like if you have $1, right? If you have $1 and you're allowed to use 5 types of coins, there are 292 ways to do that, to get those, to make change for $1. 292. But if you only have 4 types of coins, that number drops to 242, right? So that's the relationship when, like, the number of coins you can use changes, right? But then so between lines here, we have different n's. We have n is 0, n is 25, and there's 50, 75, 100. So those are like, no money, 0 cents, 25 cents, 50 cents, 75 cents, $1. Well, my argument was that, like, the whole point of finding this, right? I actually don't understand. I really don't. I actually don't understand. I keep wanting to understand, but I don't. I don't know what I'm looking for. It's like observing what happens to N. I don't know. My brain hurts. I don't want to do anymore. I don't understand how to answer this. No matter how many times I read these things, I don't understand it. Tim, I don't understand it. What do we need to keep track of at every point in the process? Only the parent nodes of the current node. How do you know? I don't know. I don't want to do this anymore. The space requirements here grow linearly. What do we need to keep track of at every point in the process? Meow, 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 meow. Meow, 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 meow. Meow. Ah, 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 ah. So the space is like, he's saying that the space is, I don't get it. Something, something, something memory. What do you need in the memory? At this step, you just need this step. And then what do you need in the memory? At this step, you just need this step. And what do you need in the memory? At this step, you just need this step. But how is that linear when there's like a tree? But whatever. Whatever. Maybe it is. Wait. 1, 2, 3, 4, 5, 6, 7, 8. Did I do the math wrong? 1, 2, 3, 4, 5, and 1, 2, 3. I don't get it. 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 I don't understand. I don't understand. I don't understand. How about the number of steps? Let's consider a situation in which we only have one type of coin. What would the graph look like? A penny and a penny and a penny. The number of nodes is 25 or 2a plus 1. 2a plus a. 23 isn't 20. Where are they getting a? What the heck is a? Did, uh, uh, Where? What is a? Wait. 1, 2, 3, 4, 5, 6, 7, 8, and 11. Hi. This tree has 36 nodes. Is that true? Wait, 1, 2, 5, 6, 30, 20, 21, 22, 23. Okay, this person made a typo. This should say 23, probably. Yeah, that's what I'm saying. So this is what I mean. This is what I mean, though, right? So, like, either this is supposed to be a 23, or... Exactly. Or, like, something is wrong, and what the fuck is A? Where is he getting 12 from? You know what I mean? Like, I don't understand, okay? 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 18, 19, 20, 21, 22, 23. There are 23. I don't know if he's calling that nodes. So then if it's 23, then he's right. It's 2a plus 1. But the fact that he has it saying 25 here makes me really triggered. I'm counting the wrong thing. Oh, what am I supposed to be counting? What's 20? What's a node then? What's a node? Sorry, what's a node? Let me research. Is that the lines? What's a node? In a tree? What is a node? Please. A single element that can store a value, a key. Am I counting the wrong thing? A single element in a tree that can store a value. I thought each point was a node. And then a node with no children is a leaf node. I don't know what you mean, Lachuka, sorry. When you say try to do the tree with 14. I don't know what you mean. Yeah, but he um some of this doesn't make sense. So in here he says the total number of spawn subtrees can be expressed as A over 5, which is 11 over 5, which is 3. Um, up. I don't know why he's. Yeah, I don't know why that equals 3, but let's just pretend that 11 divided by 5 is 3. If A is 11 and 2A plus 1 doesn't equal 25, so I don't know where he's getting. I don't know where he's getting 25 from. I don't know how he's counting 36. I think he meant to write 23, but then if that is 23, I still don't understand, like, I want to cry. Because this is just 23 for 11, so this is 23. 23. Or 20. They're like 33. But it doesn't say, like, why that even matters. Each node, if we follow the tree down the leftmost side, we see each node contains the count change process, with A being decremented by 5. Maybe this is just not a good example. Actually, I have let me go back to meow 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 meow. Meow. Where are you hiding? Where did I put you? Is it this one? It is this one. Okay, let's look here. This is 1.2. Orders of growth. Let's watch this lecture. I did ask ChatGPT, it just made me more confused. Man, am I gonna do React content? I can't even. I don't know. I forgot how to turn on the audio for UX Play. I mean, I guess I could try. Give me a second, boys. Okay. Okay, let's see. Meow, meow, meow. I got to look in the box. UX. Audio. Meow, 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 meow. Meow, 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 meow. This is the default for audio only mode. Um, um, press display stream video. As suppress playing of streamed audio. Whatever. I just see if I can edit it. Sudo vim dot display. Let's see. Right. It. Display. Hi, 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 hi. Can't believe I'm gonna do React content from the Internet Archive, but I think that's what I'm gonna do. I'm gonna try to do React content from the Internet Archive. I'm gonna figure this out. I can't believe I'm doing I don't know. Wait, I have to see if it even works. Okay, let's see if you can hear me. If I can hear me again. Ah, ah. Oh wait, I don't hear any audio. Ah, ah, ah. Or how does this work? Meow. Hmm. I don't think. Okay. Um. I need to get the audio working first. Um. Okay, um. I went too fast. Where's in here? Let's see. Um, server. That's only that. Green multi-codec. Activate HTTP live stream support. Lang list. Or I wonder. I wonder if. Okay, I think it is sharing audio, but I'm not. How do I do this? Let's see. Add audio mixer. Unhide all. See? Ah, ah, ah. Add audio input, output. Give me a second. Hmm. I hope I don't break anyone's eardrums with this. Meow. Meow, meow, meow. Okay, that doesn't do what I think it does. Delete. Uh, go here. Meow, meow, meow. Let's see. Let's see. First, I can't tell if my tummy hurts. I make this burn. What does that do? Starting audio. Uh-oh. Uh-oh. Do I hear anything? Okay. Ah, I'm sharing audio now. Okay. Need some food for the brain. Need some brain for the food. Give me... let's see. If I put the audio to there, and then what if I plug it in? What does this do? Can I listen? Oops, what does this do? Ah, ah, ah. Yeah. Okay, that doesn't do. Oops. Meow, meow, meow. I don't know. I don't know what I'm hearing. This is really bad. I don't know if I'm fixing anything. I'm breaking something out. Let's see. If I play... See if I play music. Wait. Okay, I can hear it now. But that's not exactly what I want to do. What I want to do... see. I switch this sound settings to output HDMI. Input microphone. Second line. Speakers. Digital. Hello? I hear something. Why do I hear myself? Do I have like sound mirroring on? What the heck? Filter. Man. Properties. Man. Advanced. No monitoring. Monitoring is not on. It's because I'm listening. Oh. I can hear you. Yeah, but I was wondering if you guys, I think now you guys can hear audio, but I think the quality is not good. I have no idea why I can't stop listening. Let's test. That doesn't do anything. Man, I'm really confused right now. I'm actually confused. Let me think about this. Why can't I hear myself? Or why can't I hear? Oh, because I'm not playing anything? If I play this, does everybody hear that? Or is it just me? I think it's just me. Okay, I'm getting closer. Let's see. Audio. An output source. Name is already in use. Okay. Alright. Okay, I think audio is now working. I think. This is what it sounds like. Okay. Sorry, this is so confusing for me because I'm streaming from the Linux, but I'm working on my Mac. So I had to and I wasn't sharing audio between them. So yeah, now I am theoretically sharing audio between them. That means if I play Korean rap, you all have to listen to it. But I don't know what the quality of it sounds like. So let me actually pull up the stream so I can. I think this might break everyone's eardrums, so I'm a little bit afraid. I pause this. I don't hear music. Okay. Let's see. Oh, I forgot I'm not streaming on Kick. Shit. I don't know. I don't know. Wait, Odyssey? Uh, I might not be fast enough. It's very low. Yeah, let's see. Now if I play this, hello? I might not be fast enough. It's very low. Yeah, let's see. Now if I play this, hello? I feel like there's a loop. Okay, whatever. It was really, really low. It's really low. Okay. I guess I'm just gonna have to trust you guys. I am kind of going schizo right now. I'm gonna have to trust you guys to tell me about the volume, I guess. Um, also, hi Shaco Lantern, how are you today? Let's see. Wait, let's go back. No? Okay, just play like this.
All fit in 2050 VLSP.
He's gonna teach us about orders of growth.
The first one is 2 weeks from today. We'll talk more about that later.
Actually,
Drop-in tutoring. I had a visit the other day from a student who went into the CSUA office, the one that's on the outside of the third floor entrance, looking for drop-in tutoring. Apparently she had
there is like a background noise or something or stuttering, but it's on his end. I don't think there's anything I can do about that. I think it's pretty much the video quality. Like it's a fan in a room or something like that.
pleasant experience, which shouldn't have happened, but could have been avoided by me telling you earlier, although it is in the handout, where to go for drop-in tutoring. We have HKN Eta Kappa Nu, which is the I also, every once in a while, I get an email from a this week working on programming project 1 next semester. The obvious answer turns out not to be a very good one. The obvious is quite true if you're dealing in very large integers. If you take the factorial of 500 or something, and then you try to multiply that by 3, that actually takes a time proportional to the number of digits in the number, roughly. But we're not going to think about that because mostly either you're using small enough numbers or you're using floating point representation, the ones with powers of 10.
Is it still too low?
And those things really are constant time. So here's an example.
Is it still too low?
I have a procedure squares that you've seen before. It takes a sentence full of numbers. Oops. What did I just do?
Meow.
Takes a sentence full of numbers and returns another sentence full of numbers in which each number is the square of the corresponding number in the input. Okay? Very simple program. So what I want to do is measure the running time of this program. And I'm going to say, in squares, what are the primitive operations? There's empty question mark, constant time. There's if, deciding which branch to take, constant time. There's first, constant time. There's but first, constant time. Now, square here is not a primitive operation. It's defined up in the top line of the screen, but if you look at its definition, it just does one.
Okay, let me. Yeah. I'll try to test the audio. The quality is gonna be bad though. I'll try to
empty question.
How do I make it louder? Let's see. I go into OBS. I bump it up here. What happened?
So it too is constant time. So that's 1, 2, 3, 4, 5 things that are constant time.
Okay. What happened?
So it too is constant time. So that's 1, 2, 3, 4, 5 things that are constant.
I think that got louder. I'm not sure. Let's go back. I'll try to test the audio. Yeah. The quality.
Time. Now, square here.
I go into.
So that's 1, 2, 3, 4, 5 things that are constant.
Yeah.
And then this is something a little tricky, and I wouldn't expect you to know this, but sentence actually turns out to be pretty complicated in the way it's implemented, and it has different running times for different cases. But it so happens that in this program, the way we're using sentence, in which the first argument is a single word, namely the square of one number, and the second argument is a sentence, namely the result of the recursive call, this call to sentence takes constant time also. So that's 1, 2, 3, 4, 5, 6 constant time operations, plus the recursive call. Okay? And the recursive call is on the but first of the sentence, which is a sentence that's one shorter. So how many recursive calls happen? In this example,
Shit. Ah, man. I just want to know about orders of growth, but I'm wondering if I should just watch should I just react to like all of the lectures? Because I didn't get to hear these. I'm curious.
example where I gave it 5 numbers, how many calls to squares were there altogether? Here's some 5s and some 6s. Want to vote?
6? 5?
Who says 5?
Wait, I don't know. Wait. How many calls to square are there? Square first? And I don't understand. Maybe it is 6. Oh, it is.
Okay, a little more 6.
I don't know why.
I say 6 also. There aren't 6 recursive
6,
calls, but there's 6 calls, because this one right here, maybe that you weren't counting this, is a call with sort of length equals 5. So 5, 4, 3, 2, 1, and 0. There's a recursive call with the empty sentence.
Oh.
Okay, but that call for the empty sentence only does 2 constant time operations. It does the empty and the if, and then it just returns the empty sentence, and that doesn't take any time at all. Okay? So, where did I put the chalk? Oh, over here. So for squares, a sentence of length n, we do 6n plus 2 constant time operations, right? Because the 5 calls with non-empty sentences have 6 operations plus a recursive call, and then the empty sentence one only does 2 operations. So the running time of this program should be proportional to 6n plus 2. Right? Yeah. Any questions so far? Oh, there's a hand up. Yeah. What is n? I'm sorry. N is the length of the sentence that you give as input. Okay, the number of words. Other questions? Yes. Yes, the 2 is for the if and the empty when the argument is the empty sentence in the very last recursive call. Okay? Yeah. Okay. We're going to see, by the way, in just a moment, that this is sort of too much information. And we're going to get to that because just a hint, coming attractions. We're going to end up saying, okay, the amount of time is proportional to the length of the input. And that turns out to be, oh, be quiet. That turns out to be the best thing you can say.
Okay.
About this.
It's proportional to the length of the input.
Okay. Now, here I have a function called sort.
I want to, if we look at this function though, the part that confuses me a little bit is that count change calls CC and the tree is on CC, but I don't know if that, I guess that's the part that he was talking about where it's like, I don't know. I don't know. I didn't, I don't understand the math, I think, or how to figure out the number of times it calls, because yeah, I just don't know.
And what it does is it takes a sentence of numbers and it returns a sentence containing the same numbers but ordered from smallest to largest. Okay?
Meow, meow, meow.
So we're going to look at how long sort takes. Well, this is a little bit trickier because sort has 1 empty, 2 if,
2,
3 first,
okay,
4 but first, constant time operations.
Okay, 4.
It has the recursive call to sort.
Okay, recursive.
But it also calls this helper function insert that's defined just below it. We're going to discover that insert is not constant time.
I'm in trouble. I think I need to go back and watch all of this because this makes more sense, but it makes less sense at the same time. So what I was stuck on this problem. Get sorted. But he just talked about what I was trying to say, where like when it calls a helper function, how does the math? No, I'm not sick. I'm like mentally sick. Anyway.
Well, first let me explain the algorithm to you. This is called insertion sort, and it's what you do when you're playing cards and you have a pile of cards that have been dealt.
Yeah, that's what he said. He said if empty first but first are constant, sort is recursive, and insert is a helper. And my question is, how do you look at these and figure out like how many times it's being called? I'm actually still confused about that. He did it with squares, right? And it was like there was an if empty, and that was the +2, and then it was like 6 times n or something like that. But I don't know where he said 6 because of like the calls, but doesn't that just depend on n because n was 5? Or is that coming from something else? I don't understand. N times, isn't it? Or maybe I misread what he said. Let me go back. Not that far. Wait. Oh yeah, here. He said put 6n plus 2. Where does the 6 come from? Is what I'm really confused about. Does the definition of squares, where does the 6n come from? Is it because of this? Is it because of first? But I don't know. Actually, let's just listen to him say it because I guess I glossed over it. He was talking about like other things at first, so I might have skipped too far. On that example, 6n plus 2. Yeah, but I don't know where the 6 comes from. Let's go from the beginning.
Because mostly either you're using small enough numbers or you're using floating point representation, the ones with powers of 10 in them. And those things really are constant time. So here's an example.
Amount of lengths that are repeated. Let's see.
I have a procedure squares that you've seen before. It takes a sentence full of numbers. Oops. What did I just do? No. All right. Takes a sentence full of numbers and returns another sentence full of numbers in which each number is the square of the corresponding number in the input. Okay? Very simple program. So what I want to do is measure the running time of this program. And I'm going to say, in squares, what are the primitive operations?
Okay.
There's empty question mark, constant time. There's if, deciding which branch to take, constant time. There's first, constant time. There's but first, constant time. Now, square here is not a primitive operation. It's defined up in the top line of the screen, but if you look at its definition, it just does one multiplication. So it too is constant time.
Okay,
so that's
5.
1, 2, 3, 4, 5 things that are constant time.
Okay.
And then this is something a little tricky, and I wouldn't expect you to know this, but sentence actually turns out to be pretty complicated in the way it's implemented, and it has different running times for different cases. But it so happens that in this program, the way we're using sentence, in which the first argument is a single word, namely the square of one number, and the second argument is a sentence, namely the result of the recursive call, this call to sentence takes constant time also.
So that's where the 6 comes from.
1, 2, 3, 4, 5, 6 constant time operations. Okay. Plus the recursive call. Okay? And the recursive call is on the but first of the sentence, which is a sentence that's one shorter. So how many recursive calls happen? In this example where I gave it 5 numbers, how many calls to squares were there altogether?
That's where I got confused, because he said 6, and I thought he was talking about the recursive.
Want to vote?
Thing.
Who says 5? Who says 6? Okay, a little more 6s. I say 6 also. There aren't 6 recursive calls, but there's 6 calls, because this one right here, maybe that you weren't counting this, is a call with sort of length equals 5. So 5, 4, 3, 2, 1, and 0. There's a recursive call with the empty sentence. Okay, but that call for the empty sentence only does 2 constant time operations. It does the empty and the if, and then it just returns the empty sentence, and that doesn't take any time at all. Okay? So, where did I put the chalk? Oh, over here. So for squares, a sentence of length n, we do 6n plus 2 constant time operations.
Okay. And that's ignoring squares, the recursive part. This is just the constant time operation. I don't even know.
Right?
Okay.
Because the
I'll just
5
let it go.
calls with non-empty sentences have 6 operations, plus a recursive call. And then the empty sentence.
Oh no, it is included.
One.
Wait, 5 plus. I keep getting confused. 5 plus. Let me listen to him.
Calls with non-empty sentences have 6 operations, plus a recursive call. And then the empty sentence one only does 2 operations. So the running time of this program should be proportional to 6n plus 2.
If you say so, sir.
Right? Yeah. Any questions so far?
I have so many.
Great. Oh, there's a hand up. Yeah. What is n? I'm sorry. N is the length of the sentence that you give as input. Okay, the number of words. Other questions? Yes. Yes, the 2 is for the if and the empty when the argument is the empty sentence in the very last recursive call. Okay? Yeah. Okay. We're going to see, by the way, in just a moment, that this is sort of too much information. And we're going to get to that because just a hint, coming attractions. We're going to end up saying, okay, the amount of time is proportional to the length of the input. And that turns out to be, oh, be quiet. That turns out to be the best thing you can say about this. Okay. Now, here I have a function called sort. And what it does is it takes a sentence of numbers and it returns a sentence containing the same numbers but ordered from smallest to largest. Okay? So we're going to look at how long sort takes. Well, this is a little bit trickier because sort has 1 empty, 2 if, 3 first, 4 but first, constant time operations. It has the recursive call to sort, but it also calls this helper function insert that's defined just below it. We're going to discover that insert is not constant time. So first let's look and see, well, first let me explain the algorithm to you. This is called insertion sort, and it's what you do when you're playing cards and you have a pile of cards that have been dealt in front of you and you pick them up. If you're me, you pick them up in your left hand, because I'm left-handed. Maybe you pick them up in your right hand. And then one at a time, you transfer the cards from this hand to that hand. And so we start by taking any old card and moving it to the other hand. Then we take another card and we put it either before or after the one that's already there. And then we take the next card, and there's 3 places it might go: at the beginning, inside the other 2, or at the end, and so on. For each randomly chosen, whatever order we got them in card, we insert it into an already sorted hand, okay? So the trick about insert is that it takes one new number, and it has this argument sent, which has to be a sorted list of numbers. So sent is already in order first to last, and we're inserting one new number into it, right? Okay. How long does this take? It's a con, so it's a 3-way choice. Here's the base case. Sent is empty, in which case we return a 1-word sentence containing the number. So this turns out to be constant time. If sent isn't empty, then we can compare the new number we're inserting with first of sent. We can say, is this new number smaller than first of sent, and therefore smaller than everything in sent, because we're assuming sent is already sorted, so we're comparing the new number with the smallest number in sent, which is also the first number, okay? So this is 2 constant time operations, first and less than. And if that's true, we do this sentence, which is constant time because it's adding 1 word in the front of a sentence. If we were adding the word in the back of the sentence, it would take longer, turns out. We'll get to that next week, why that is. And here's the else clause. And what the else clause does is it says, okay, this new number is not the smallest. First of sent is smaller or equal. Doesn't matter. So my result should start with first of sent, because first of sent was the smallest number in sent, and it's also smaller than num, which is the new one we want to add. So therefore, the first number in the result should be the first number in sent. And what do we combine that with? A recursive call in which we're trying to insert the same new number into but first of sent. So basically, we're going to march down this sent until we hit a number that's bigger than the new one, and we're going to end up inserting it right there. Okay? Let me actually show how this works in a moment by saying trace sort, trace insert, and then do this again. So it's a little tricky. Here we go. So I'm calling sort with the whole sentence.
I wonder if I can do trace in chicken. I have to check.
That, you can't see this, but it says, is the sentence empty? No, it's not. Is the first of sent? Oh, because, I'm sorry, what sort does is it takes first of sent and it uses that as num in the call to insert, and it also sorts but first of sent. So what we're doing here, we're looking at this sentence, 6, 23, 5, 10, 107. And before we can do anything else, before we can call insert, we have to sort the but first of the sentence. So first thing, we sort 23, 5, 107. And that starts by sorting 5, 107. And that starts by sorting 107. And that starts by sorting 7. Oops. And that starts by sorting the empty sentence right down here. So we call sort, boom, 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 boom. Sort the empty sentence. That's the base case of sort. It returns an empty sentence. And now we can start inserting. So we want to sort this sentence. So we end up calling insert with num is first of sent, which is 7, and sent is the sorted version of the empty sentence, which is also the empty sentence. So in that situation, we're in the base case of insert right away. We're
It's
inserting
empty.
into an empty sentence. So it immediately returns the sentence of length 1 with a 7 in it. And because insert returns that, that's what sort returns. So that innermost sort here returns sentence with 7. Oops, I'm sorry, sort, there it is. And so that's this value here. So 7 was just the first number that happened to be in the sentence, not necessarily the smallest. So now I'm going to take, I'm sorry, the last number that was in the sentence. It goes right to left. So now I'm going to take the number before it, which is 100, and I'm going to try to insert 100 into this sentence. So insert says, is sent empty?
No.
No, it isn't. Okay, let me compare num, which is 100, with first of sent, which is 7. And it asks the question, is num smaller than first of sent? And the answer is no. Num is 100, first of sent is 7, so num is bigger. So therefore, I'm going to do this recursive call to insert. I'm going to insert 100 into the empty sentence. That's the base case for insert. So it returns this sentence with just 100. And then we're back here inserting the 7, by sentencing, the 7, which is now the smallest number of the ones we've looked at, in front of the result from insert. So insert returns 7 100. So therefore, this recursive call to sort returns 7 100. And now we get the next number, which is 5. Oops, let me move this up a bit. So I try to insert 5 into the sentence 7 100. This time we're lucky. 5 is smaller than 7. So without even trying, we know that 5 is smaller than 100, because we know that sent is in order. So 7 is the smallest number in it. So we can just stick 5 in the front. Insert right away returns this, and so does sort. And then we go to the next number, which is 23. We're trying to insert this here. This time we weren't so lucky. So 23 is bigger than 5. So I'm going to try to insert num into but first of sent, which is 7 100. 23 is still bigger than 7. So I'm going to try to insert 23 into the sentence with just 100. This time we are lucky. Insert sticks just sentences 23 in front of the 100. And then the next call up sticks the 7 in front of that. The next call up sticks the 5 in front of that. That's all the numbers we have. So the recursive call to sort returns this sorted sentence. Now we're all the way out to the beginning of the original sentence. So num is 6. We're trying to insert that into 5, 7, 23, 100. 6 is bigger than 5, so we do a recursive call to insert. 6 is smaller than 7, so we just stick it in front. Then we stick the 5 in front, and that's what sort returns. Okay? It's pretty quick, but I think the algorithm is not that bad. Questions? Yeah. Mm-hmm.
Meow, meow, meow. Oh, I gotta watch all of
Okay,
these.
good question.
I miss too
The
many.
question
I'll go
is,
back
since
and
sent
watch.
is empty, why do I have to do this? Why don't I just return num? And if the overall input that I started with is more than one number, that would in fact work, because sentence is very forgiving. And you can do sentence of a word and a word, not just a word and a sentence. But if I did it your way and I said sort a sentence with only one number in it, it wouldn't return a sentence. It would return just the number, because that's what insert would return. That's not so good, because somebody else who's calling sort expects to have a sentence And even if it's a sentence of length 1, they're going to be, butt firsting down the sentence looking for words in it. So my overarching answer to this question is domain and range. Always remember domain and range. So in particular, as we're writing insert, we say, what is the range of insert? That is to say, what kind of thing is insert supposed to return? The answer is it's supposed to return a sentence. So that's true even in the base case. We have to make sure we're returning a sentence, and that's what this does.
Meow,
Okay?
meow, meow.
So it's a much better way to think about things than, wait, I could get away with shaving, one instruction off of this program by having the base case not in the range, but something else instead. Don't think like that. You'll get all messed up. Wait until we get to trees. You'll die if you think that way.
Wait, so is he not going to go over trees in this
I'm
one?
supposed to return a sentence. I'm going to return a sentence in every one of these 3 cases. So you'll notice that, in fact, every one of these 3 cases calls the constructor procedure sentence to produce its result. Okay?
Meow, meow, meow.
Yeah. Yeah, if you didn't have SE there, it would just return the word. So that's what num is. Yeah. Here, we're talking about this. We've just checked and we've discovered that sent is empty. So we know what, so we're just making a one-word sentence. If it said, here, if I put sent right here, where the cursor is, before this close parenthesis, it would be okay. I would then combine num with an empty sentence. But it wouldn't help, because I know what happens when you combine one word with an empty sentence. You get a one-word sentence. So I'm just asking for that directly. It does create a sentence. Are you saying does it clobber pointers to change something? SE is a function. It doesn't change any of its arguments. Okay? Functions, that's an important point. You programmed before in high school or something, right? Yeah. We're doing functional programming. Never ever are we going to write something for the first month and a half of this course that changes the value of anything. It's always going to be creating a new value. Okay? That new value might or might not share memory. If you're worried about space efficiency, the answer is it's none of your business how it does it under the hood. You just worry about the value of what you get. Okay? Yeah.
Meow. Meow, meow, meow. Professor, do more, do more, do more.
Okay, he wants me to insert values into an array. In functional programming, we do not change the value of anything. We don't set up some data structure and then put things in it. We write a function that returns a value, period. Okay, you have to, people who've programmed before in some other paradigm, you really have to try to think in functional programming terms and not try to solve this problem the way you were taught in high school or the way you were taught in community college or the way you were taught in E7. Okay? Don't think about what data structure should I build. We don't build data structures. Think about what is the value that this function is supposed to return. And you make an expression whose value is that value, like this. This is an expression whose value is the thing that we want sort to return. Okay? Do that. You have to think like that. I'm not mad at you, but think like that. It's a good question. Everybody else wants to know that too. Everybody who went to high school had the same thought in their minds. So don't feel bad. But those of you who didn't go to high school, you're doing fine. Okay. All right. So Subproblem, what's the running time of insert? Well, I see 1, 2, oops, empty, 3 less than, 4 first, 5 sentence. Sometimes we get 5. Sometimes it's 5 sentence, 6 first, recursive call, 7 but first. Okay, so the time for insert, subproblem here, is either if the input sentence is empty, 3, or 5. If num is smaller, or something in between. The actual running time depends on how lucky we are. Maybe it's just 5 altogether if num is smallest. Maybe it's 7 plus 5 if num is second smallest. Or 14 plus 5 if num is third smallest. The worst it can be is 7n plus 5. Actually, probably 7n minus 1. So I mean that 7 times n minus 1, right? No, 7n, because n is the number of things in cent, not including num. So this is the worst case. So when we're trying to figure out how long sort takes, what we're going to do is assume the worst case. That's the most conservative assumption. We can also say, on average, the number we're trying to insert is going to be halfway down. Right? So we could say 7n over 2 plus 5, average case. Right? So that's another way to think about that, to keep in the back of your mind. But generally speaking, it's easier and more helpful to think about the worst case in estimating running time of a program. Okay? So given that, how long does sort take? Well,
no idea.
Sort has 1, 2, 3, 4 constant functions, plus a call to insert, plus a recursive call.
Okay.
So there's n recursive calls, right?
Got it.
So the result for sort is going to be n times something, plus a constant of 2. What's the something? Well, it's 4 constant things plus the worst case for insert.
7.
Right? Okay, which is 7n squared plus
multiplied.
9n plus 2. Everybody happy with this?
No, I can't see the board. Professor, I can't see the board. Please, show me the board.
Okay, somebody whose thumbs down, ask a question. Yeah, no? What's the 2? The
Meow.
2 is the if and the empty in the final base case of an empty sentence.
Okay. I want to
Any questions?
pause. I should let him cook. But in here, for count change, CC is like, what did he call it? A helper function, helper procedure. DC has a cond, which has 3 conditions, right? And the conditions are equals if amount is equal to 0, or was the comparison. So if the amount is less than 0, or if kinds of coins is 0, and then otherwise this thing, recursion. And then, but then inside of the recursion, there's also first denomination, which also isn't, which is also another helper, I guess. So, yeah, I don't know how to count. I don't know how to count this. I guess, so like, I did learn something, what he said about, the ones that are constant. So like, equals, probably. Less than. Not a wizard, I'm confused. But every time there's CC, that's recursion. I don't know. I forgot how he did that math. I don't know what that means, Mamo. I have no idea what that. But grats. I'm glad you learned something.
Yeah. Oh, 3. No. Most of the time, that's only, he wants it to be 7n plus 3, not 7n plus 5. Most of the time, almost all the time, the new number that we're inserting is going to be somewhere other than the very end. So when we get to a number bigger than it, we're going to do 5 steps. That's the second case of the cond, which is also a base case. There's no recursive call in the second cond clause of insert. Does that answer your question? Yes, the very worst case, you're right, would be that, but if you think about the big sentence that we're trying to sort, we're only going to get to that worst case like once, unless we're so unlucky that we get the numbers in inverse order, backwards order or something, okay? Yeah. Uh-huh. Ah, yes. Good question. You get a gold star. He wants to know, this makes up for you wanting to put things in arrays. He wants to know, isn't it the case that each call to insert has a different size cent, right? It's not that we're going to make n calls to insert, and each of those calls to insert has a sentence of length n to work with. We're going to make an insert into an empty sentence, and then insert into a one number sentence, and then insert into a 2 number sentence, up to insert into an n minus 1 number sentence. So really, this should be 7n over 2, and this should be 7n squared over 2. What? Right? Because on average, we're inserting into a sentence of length n over 2. Okay? Now, I said we're only doing 1 week of this. In 61B, you'll get a much better treatment of this whole topic. I am hand-waving a lot by saying, okay, 7n over 2. It's the right answer. But I have not proved that it's the right answer.
Yes.
Okay, next semester you'll actually do that.
Oh man, so you're telling me that I have
it's
to...
actually...
You're telling me... So, okay, I knew that I was overdoing this problem, but it seems like I need to, Why did you fart? Get out of here. Why did you fart? Yeah, he just told me that I have to take the whole course and then take the next course to learn what I'm trying to figure out. Buddy, guy, man. Okay, I don't feel like doing any more. I said that this was going to be a 7-hour stream today. I don't know if I said that, but I thought it. I don't know if I said it out loud. I don't know if I named it that, but that was the plan. Oh yeah, it is in the title. Yes, I did write that in the title. So that means stream is pretty much over now. I'm really sorry to anyone who's with me all day as I try to figure this out, but also, like, thank you, and, like, yeah. Do more next time. Let's see, we're gonna end the screen, and then we're gonna just rage quit this, and then, I wonder if this is gonna get copyright struck, because I played copyrightable music for a little bit. Even though it was only a very, very little bit, I just thought of that now. I could probably get in trouble. Man, I am rage quitting. What I think I'm gonna do, now that I've figured out, how to... So, like, I haven't figured out the problem. I haven't figured out what I was trying to do for the problem. But one thing I have been trying to figure out is how to share audio with the Linux and my Mac. Since I've done that, I think I will do more kind of like... we could call it like a watch along instead of a react. Something like that. And I wanted to do this, but then I said I wasn't going to. But since I could share it with you guys, I think, yeah. I think we're just gonna binge watch lecture 1 and 2 for sure. And then maybe we take a look in some of these lectures. I'm wondering now too, though, because, like, they're using the same book that I'm using, but it's not in order. They cover 1.3 before 1.2 to 1.4, so that's something to consider. But I'll do at least the next 2 lectures. Yeah, I don't know if it'll be fun for you, but it's gonna be useful for me, so I'm gonna focus on the utility. Anyway, man, I do not think this was supposed to be this hard. I am really excited. So the other thing I've read about this book is that it's like it's math heavy, front loaded. Yes, I'm broadcasting audio across devices right now. It's homework for the chat. Yeah. Homework for the chat is, if you can explain, like, not even all of this, just this part. What are the orders of growth of the space and number of steps used by this process as the amount to be changed increases? If you can explain this to a dumb cat girl, like she's 5 years old, explain like I'm 5, but also not just for this case, but how you go about doing it. Because the thing is, like, I see a lot of I see a lot of people posting their solutions to the problem, but though like the one that I showed you guys, it was riddled with some very obvious mistakes, and I felt like it was making jumps in logic that I couldn't follow. Meow, meow, meow. The journey is the destination. Oh, I like that. That's really clever of you. And then I'm also gonna just kind of casually avoid. Man, I don't want to do trig. I don't want to. I thought I would never have to see radiance again. Damn it! Damn it! It came back to haunt me. No, trigonometry, leave me alone. Do it. I'll ask my brother. I mean, you don't have to, Mamo. This is not like it's not like a special assignment to you or something like that. I was just kind of anyway. Okay, be quiet now. Anyway, yeah. It's been 7 hours. Have a good day. Bye.